All right, so let's go ahead and get started with this lecture on RMS values. First, I need to talk about something called the average value of a signal, which leads me into the reason why we use RMS values to begin with. But basically, the average value of a signal. So if I have a signal, let's just make it a square wave. We'll make this t over 2, this t. I guess we can put 2t here. Just going to draw a square wave. Maybe a different color would be better. Okay, so it's going to do something like this, and on and on. And let's just say that it has a high value of VH. And it's obviously got a 50% duty cycle. And so the average value of the signal is basically the value that the signal swings around. It can also be thought of as the DC offset of the signal. I think it's more helpful to think of it as the value that the signal swings around. And so it basically swings around a value right here. I guess the question would be, what is this value if we wanted to calculate it? It's pretty straightforward. We just use this formula here. It's basically taking the average just like you normally do. You know, with an average, you typically add up all the numbers. So like if I wanted to take the average of 3, 5, and 7, I would add them, 3 plus 5 plus 7, and then divide by the total number of values, which in this case is 3. And I get 8 plus 7 is 15 divided by 3, so my average value is 5, right? That's how we find the average. Well, when we find the average value of a signal, we do something very similar, except it's a continuum, right? So we have an infinite number of values that we're adding up. That's what an integral is, right? It's summing all the values from 0 to t of my signal, and then it's going to divide them by t, which is the period. So this is how you find the average value of a signal. So if this is my signal here, let's just call it Vx of t, and it has a high value of Vh. I could write my signal Vx of t is equal to, and it would be a piecewise function, that is Vh for 0 less than t over 2, and it's 0 from t over 2 to t, right? And so if I wanted to find the average value now, I can just plug it right into my formula. So I can say Vx average is equal to 1 over t times the integral from 0 to t of x of t, which in this case is, well, I have to actually switch up the bounds of my integral, right? It's only going to be Vh from 0 to t over 2, and then from t over 2 to t, it's just 0. So this goes to 0, and I'm just left with 1 over t. I can actually pull the Vh out, so I'm going to get Vh over t times the integral from 0 to t over 2 dt, and then that is going to be Vh over t times t over 2 minus 0. The t's cancel, and I'm left with Vx average is equal to Vh over 2. Okay, so that's pretty straightforward. So I found that the average value of a 50% duty cycle square wave is Vh over 2, which maybe you could have guessed. And obviously, if I were to increase the duty cycle of this signal, then the average value would increase all the way until the duty cycle is 100%. And when the duty cycle is 100%, then we just have a DC signal who the average value is the value itself because it's DC, right? And so that's kind of the neat thing about finding average values of signals. It's very important. It's very useful in power electronics and power analysis in general. The question is, what the heck is RMS, which we haven't talked about yet? And so I'm going to go ahead and end this video here since I've sort of covered an example of the average value of a signal. And in the next video, I'm going to start talking about what RMS is, and I'm going to motivate it from something that we learned in this video, showing what happens if we were to shift this signal down to where it's basically swinging around 0. Maybe you already know what would happen, but I'm going to go ahead and end this video, and we'll talk about that in the next video, and then we'll start talking about RMS values.